Hello everyone. Today I am going to take the topic class hierarchy. I would like to thank my team member for creating this presentation. Simi Sebastian, Sruti Soman, Sumitra T for references and PPT, Tipsy Abraham, Vishal Nair, PPT and Flipgrid. Class hierarchy. A class hierarchy is nothing but classification of object types. To understand, we should know what is class and object. A class is like a blueprint. Object An object is what built from the blueprint. For an example, a robot. There are different types of robot and each has its own unique functions. So the robot is class and robot with unique function is an object. So the concept of class hierarchy is similar to taxonomy. It is based on OOPS design or object oriented programming design and is used in many programming languages such as Java, C++, etc. It can be classified entity into subclasses: specialization, generalization, and aggregation. Generalization: extracting common properties from a set of entities and creating a generalized entity from it is known as generalization. It has a bottom-up approach where two or more entities are combined to form a higher level entity if they have some attributes in common. The similarities among lower level entity set and to hide difference in the schema are some features of generalization. In other words, it sums up the information into a small class. Second one. Example. Consider we have three sub-entities: car, bus and motorcycle. Now these three entities can be generalized into one higher level entity or superclass named as vehicle. Car, bus, motorcycle, these are subclasses and vehicle is a superclass. So car, bus, motorcycle have same characteristics such as they are used for transportation, they carry people, they consume fuel. So these three subclasses have same characteristics and these all characteristics are common, so they are known as vehicle, which is a superclass. So it is a bottom up approach, from bottom to up: car, bus, motorcycle to vehicle. Specialization: it is just the opposite of generalization. Entity is broken down into subclasses based on characteristics. It is a top-down approach. Identify subsets of an entity set that share some distinguishable characteristics. Can be applied to refine the design of the schema. Example. Here it is a top-down approach. Vehicle entity can be a car, bus, motorcycle. Normally, the superclass is defined first. The subclass and its related attributes are defined next, and relationship sets are then added. So, vehicle is a car, vehicle is a bus, vehicle is a motorcycle. It's a top-down approach. Specialization: all the attributes of superclass is being inherited to the subclasses. For example, transportation, consuming fuel, and number of people it can occupy. All these number of Inheritance. When a lower level entity inherits the attribute of higher level entities is known as inheritance. They are important feature in generalization and specialization. Let's take an example. In this case, vehicle has attributes make, model, chassis number, and vehicle is a car, can be a bus, can be a motorcycle, and each car, bus, motorcycle has its own attribute: stereo present, seat number, and load capacity. On the basis of generalization and specialization, it can be defined by bottom-up approach and top-down approach. Next is how schema or table can be formed. So in this case, a person can be an employee, can be a customer with attributes. An employee can be a officer, teller, secretary. So the ending nodes, the officer, teller, secretary, and customer can be example on relationships of relationships. Basis CR model can't represent relationships involving other relationships. Consider a ternary relationships work on between employee, branch, or jobs. An employee works on a particular job at a particular branch. Suppose we want to assign a manager by jobs performed by an employee at a branch. That is, want to assign a manager to each employee, job, branch combination. Need a separate manager entity set. Relationship between each manager, employee, branch, and job identity. The next is redundant relationship. Relationship sets works on and manages represents overlapping redundant information. Every manager's relationship corresponds to a work on relationship. However, some works on relationship may not correspond to any manager's relationship, so we can't discard the works on relationship. Aggregation. Eliminate this redundancy via aggregation. Aggregation. Relationship among relationship. Aggregation. It is a process when a relationship between two entities is considered as single entity, and again this entity has a relationship with another entity is aggregation. Eliminate this redundancy via aggregation. Treat relationship as an abstract entity. Allows relationship between relationships. Abstraction of relationship into new entity. Example, aggregation. With aggregation, without introducing redundancy, the ER diagram can be represented as follows. An employee works on a particular job at a particular branch. An employee branch job combination may have associated manager. From this diagram, we can understand the aggregation. Conclusion. Subclasses are classes that are derived from another class. This means that they inherit the functionality of class they are derived from. Then they add something to this functionality. Superclasses are classes from which other classes have been derived. Class hierarchy can be viewed one of two ways: specialization, generalization. Specialization top-down approach, generalization bottom-up approach. Thank you very much.